for being here. Thank you for checking in. I would want to encourage you to have the notes from part A. What we created was a random example of a quadrilateral inscribed in a circle, and then we measured the actual like angles and could verify, other than human error, that this random quadrilateral has opposite angles that are supplementary. We're going to dive into how to prove it formally. This is geometry. This is the part of geometry where we talk about logical proof. And part of a logical proof is the brainstorm that you have to do before you can actually write a formal paper. There's a lot of like literature in the structure of writing in this class. So let's continue the brainstorm. Please have the following note cards handy. Reminder, intercepted arc needs to be visible. Definition of supplementary angles. Our pal, substitution property. The distributive property, which you might need to make fresh for the first time, just so you know that it exists. And then, this entire video and this sequence of videos has been on the inscribed angle theorem, which says that the measure of an inscribed angle is half of the measure of its intercepted arc. And it started on page 360. So, if you haven't yet made this note card or any of those ones, pause the video right here, refresh it, give me some views, but give that chance to go create those and then have them handy. This video is still about brainstorming our proof. Remember, we want to go from a random example to some more structure. You always want to try it out just to see if like it's plausible, which means maybe it could happen. Once we know that it's plausible, then we start to formalize it. Part of formalizing is to actually bring in some letters. So here's some letters that I'm going to bring in. I'm going to bring in, where'd the 101 come from? Right? Let's actually go ahead and mark that down. And so I'm going to move me over to here and kind of make this like be like that, right? Okay. The 101, right? It's this angle. So I'm going to call it, I could use like 3 letters to name it. I'm going to use just one. I'm going to say it's just angle Q. And then let's maybe put me over here. Okay. So angle Q, that's what I mark here. Angle Q. Oh, we need the letter M, right? Measure, it produces a number. So the measure of angle Q is 101, and that means that the measure of angle A is 180. Right? That should be true for everything. Whatever you created, whatever circle you drew, and wherever you put your points, no matter how big the circle or small, angle Q and angle A are going to add up to 180. At least that's what we're hoping, right? We're going to try to prove that. But here's our observation. We saw this from observation. So therefore, the measure of angle D is 92. And we're going to add to that the measure of angle U. Little pen typo mistake. Those together also, this is supposed to be a U, all right? Those together also add up to 180 degrees because there they are, right? We created a random circle. We measured the angles of the sides that are created, drew the secant lines so that they would actually go through the protractor. And yeah, we've got some letters now. Okay, if we know that information, we can say then that angle Q and angle A are supplementary, right? If you know that they add up to 180, then I'm going to kind of put that note over here. I'm going to slide my camera down just a little bit. Okay, if I know that angle Q and angle A add up to 180, then I can literally just say this. I can say that angle Q and angle A must be supplementary because of the definition of supplementary angles. Angle Q and angle A are supplementary. And then we can also say the same thing about angle D and angle U, right? If 2 letters, 2 angles add up to 180 degrees, they must be supplementary. So because of that reason, we can also say this one. We can say angle D and angle U are supplementary. Where have I seen that before? There was something, right? Oh, my paper's dropping. My paper's out of the book. There was something in the book, right? Something in the book that said, oh my gosh, it's the proof. Look at this, right here. Angle Q, oops, can't see it. Angle Q and angle A are supplementary angles. I've said that on my paper, on my notes. Angle U and angle D, I guess I switched them, but angle U and angle D are supplementary angles. That's also on my notes. So check it out. There is a way to go from adding the measures of the angles up to this sentence. We're getting to the proof. That's the whole point. We have a circle, we have a quadrilateral in the circle, and we've got opposite angles adding to 180, so therefore they are supplementary. There's a part that's missing. How do we know that in the circle that's 101 degrees without always needing to measure it with a protractor? How do we know? So let me flip through my cards. We have definition of supplementary angles. That's probably actually what's going to bridge those arrows. This is why. We have a substitution property. Hey, substitution's probably going to be in our statement at some point. We've got the distributive property. We've got these two. We've got intercepted arc. The central angle is equal to the measure of the intercepted arc. Maybe I don't need that one, but I do want to comment on where the intercepted arcs are. That's what I'm going to do. Okay, so there's actually, I'm going to highlight Q green. Angle Q, I'm going to highlight green. And if I extend it all the way out to the circle here and extend this ray of angle Q out to the circle U, all of this, highlighting green intentionally, all of that is going to be the intercepted arc of angle Q. Angle Q is an inscribed angle. So if you've been paying attention along the way, where when we did our notes for inscribed angles, the measure of an inscribed angle is half of the measure of its intercepted arc. So I can say this statement right now. I can say right here, angle Q, the measure of angle Q is 1/2 the measure of the arc that it's across from. So angle Q has UAD as its intercepted arc. Okay. Also, different colors. I got 4 highlight colors happening here. Let's go with angle A. I'm going to highlight angle A pink. So we're supposed to be focusing on opposite angles, right? That's the goal. Focus on opposite angles. So angle A is across from angle Q. And then I'm going to highlight the intercepted arc created by angle A. So that means I'm going to go from U to D. U, DQ, UQ. Together, all of this is the intercepted arc, right? That's the vocab word I'm trying to highlight. All of this is the intercepted arc of angle A, UQD. And by the inscribed angle theorem, this measurement in angles is going to be twice as big as the angle measurement at angle A. So I'm going to say that too. I'm going to say right up here, the measure of angle A is going to be 1/2 the measure of its intercepted arc. So the intercepted arc is UQD. Oh, I noticed that Q and A are the matching middle letters. Interesting, interesting. Okay. Hold on. All of arc, all of the pink arc here, all of UQD plus DAU, that's a full circle. Okay, so in a circle, the number of degrees of a full circle is 360. Okay, so we have this. We have the opportunity to just say, let's just add arcs together. Arc addition postulate, remember that one from your Matheo homework, workspace 2, maybe workspace 3, that the arc addition postulate says if you add up arcs, you get their sum total of the angle measures. These arcs make a full circle. So UQD and UAD make a full circle, add them up, they make 360. Let me put that up here. The measure of UQD, just like here, but this is half, so there's probably going to be some half coming in, plus the measure of DAU, or I'll go the other way around. I'll use these letters, UAD, is 360 degrees because they make a circle. I don't have that one. I do. I know that I would use it. I can divide both of these things by 2, right? I can take and divide this by 2, divide this by 2, and divide this by 2. There's a clever reason, right? UQD, if I divide by 2, is this thing. 1/2 UQD, divide by 2, 1/2, divide by 2, same thing. And divide UAD by 2, that's this one. 1/2, divide by 2, 1/2, divide by 2, same thing. So then, last part, 360 divided by 2 is 180. Oh, ho, ho, my 180 is happening. It's happening. And so therefore I can say this. Oh my God, I'm almost done. Let me get a different color in. Half of the proof at least. I'm just gonna like copy the proof for the other one. Here we go, here we go. Okay, do this first. Establish a circle. Do this second. Establish the intercepted, or no, establish the inscribed angle theorem. That's 2. Do this third. Divide by 2 using the division property. Do that third. We can divide through. They're just numbers. They just, you know, they're random numbers, but they are just numbers. Do that third. And then swap. Lots of arrows, I'm sorry. Rewatch the video for the steps. Swap, substitution, or PAL. Substitution is gonna happen fourth. And then last of all, since you get to say that they're swapped, they equal 180. Oh, this is angle addition. Wait, whoa, whoa, whoa. Substitution. It's substitute. It's already set up. Yes. Okay, then down here, this is fifth. 5 steps. Stick around for part 2, where we take those 5 steps and we put them into a proper flow proof. Oh my gosh, chills. Love it when a proof starts to work out the way we intended to. See you in the next video. Like, comment, and subscribe. Click the word. See you in the next one. Bye.